In this video, we're going to be covering hypergeometric distributions. For a hypergeometric distribution, the sample data are selected without replacement from a finite population. What does that mean? Well, that means the events are not independent, so the probability does not stay the same between each selection. So our formula for this is the probability that we choose X events, or that X events occur, such that, and we're given some other variables here, lowercase n, a capital N, a capital E, and our formula is E, choose X, times capital N minus E, choose lowercase n minus X, all divided by capital N, choose lowercase n. Now, what are those values? So let's write that out. So lowercase n is our sample size. That's similar to everything we've done in the past. Capital N is population size, so that should also look familiar. Furthermore, we have capital E is the number of events of interest. We also have lowercase x as the number of capital E is the number of events of interest in population. And lowercase x is the number of events of interest in the sample. And considering this, then of course we get x is equal or less than E, and x is equal or less than lowercase n. That must be true, right? The number of events of interest in the sample must of course be equal or smaller than the total sample size, and of course it must be equal or smaller than the number of events of interest in the entire population. And of course all of those things, lowercase n, capital E, and x, must be equal or less than the population size. Okay, so a few things we want to say about that. First, the mean of the hypergeometric distribution. Just give us, sorry, that's off the page, or it's off the video. The mean of the hypergeometric distribution is given by mu is equal to E of x, so it's just a different notation. And this is lowercase n times capital E all over capital N. And we also have the standard deviation, and this is sigma is equal to the square root of lowercase n times capital E all times capital N minus E divided by capital N squared, and this is multiplied by the square root of capital N minus lowercase n over capital N minus 1. Okay, and so that would be our formula for the standard deviation. Don't worry so much about where those formulas come from, that's just what they are. And so, yeah, that's it for the formulas for this section. So in a related thing, we would like to go over an example. So I will do that now. So the example we are going to do here is to suppose that we have a financial analyst is facing the task of selecting mutual funds to purchase for a client's portfolio. Suppose the analyst has narrowed down the selection to 12 mutual funds, 6 of which are growth funds. The question is, if 4 funds are selected, what is the probability that, and we're going to have a few different questions we're going to ask. The very first one is, exactly 1 growth fund is selected. Well, the very first thing that we want to do is determine what the capital N, lowercase n, x, and capital E are in this situation. So, let's do that. First, capital N is our population size. So what should that be? Well, that should be 12 here. Because we have narrowed it down to 12 mutual funds to choose from. Then, what is lowercase n? Lowercase n is our sample size. So this is the size that we're actually choosing. Well, this would be 4 funds are selected, so we're actually choosing 4 funds. What is our capital E? That is the number of growth funds in the population. So that number of growth funds in the population is 6. And then lowercase x is the number of events of interest in the sample. Well, our question asks for what is the probability that we get exactly 1 growth fund. So here, x is 1. All right. So we just need to plug into the formula then. So this tells us that our probability of exactly 1 growth fund here is equal to, all right, we had capital E choose x, so this would be 6 choose 1, times capital N minus E, so that would be 12 minus 6, so again this is 6, choose lowercase n minus x, so this is choose 4 minus 1, so that's 3. All divided by capital N choose lowercase n, so this is 12 choose 4. Sorry, not 6, 4. And this is our probability. Now, we would probably also like to figure out what this actually is and give us a slightly better result than writing this out as a function or expression of a bunch of choose functions. So let's actually determine what this is. All right, the choose function says this is, if this is a and b, this is a factorial divided by a minus b factorial times b factorial. And then 6 choose 3, so this will be 6 factorial, all divided by 6 minus 3 factorial times 3 factorial. And this is all divided by 12 factorial over 12 minus 4 factorial times 4 factorial. We can keep narrowing this down. This is 6 factorial over 5 factorial times 6 factorial over 3 factorial times 3 factorial, all divided by 12 factorial over 8 factorial times 4 factorial. Well, what is that? Well, this is equal to, all right, 6 factorial over 5 factorial. That's 6 times 5 factorial over 5 factorial. Then we have 6 factorial, which is 6 times 5 times 4 times 3 factorial, divided by 3 factorial times 3 factorial, all divided by 12 times 11 times 10 times 9 times 8 factorial, divided by 8 factorial times 4 factorial. So, let's see, here in the denominator, the 8 factorials cancel. Up here in the numerator, the 5 factorials cancel, and these 3 factorials cancel. So we keep narrowing this down. This is 6 times. Oh, then we have 6 over 3 times 2 times 1. So 3 times 2 times 1, 3 factorial is 6, so those cancel. So we get times 5 times 4 here, all divided by 4 factorials, 4 times 3 times 2, so 4 times 3 is 12. So that would just leave if the 12 and the 4 times 3 cancel, so this would just leave 11 times 10 times 9 over 2 in the denominator. So that's 10 over 2 is 5, so we get 11 times 5 times 9 here in the denominator. And you could calculate what that is. I might just leave that here. Or actually, we can do that. The 5s cancel. That's easy. 6 times 4 is 24 over 99. And so our probability is 24 over 99. All right. Well, what if we continued to ask a similar question now? And part B is going to ask, what is the probability that we have at least one growth fund is selected? Well, this is 1 minus, this should be 1 minus what? Well, this should be 1 minus selecting 0 growth funds, right? If we select 0 growth funds, the complement of that is selecting 1 growth fund, 2 growth funds, 3 growth funds, or all 4 are growth funds. So 1 minus the probability that you select 0 growth funds is exactly the probability that we get at least 1. So 1 minus p of 0 is what we want. So we need to go and determine what p of 0 is. I'm going to turn over the paper so I have more room. We'll turn over this paper. So let's go ahead and do that calculation now. So p of 0 is, all right, so this should be 6 choose 0 times n minus e, that is still 6, lowercase n minus x, so this should be 4 minus 0, so that'll be a 4, all divided by capital N choose lowercase n, that is still 12 choose 4. So this is p of 0 now. So this is 6 factorial over 6 minus 0 factorial times 0 factorial. And this is all times 6 factorial over 4 factorial times, 6 minus 4 factorial. Wrote it in a different order than I've been doing. That's okay. All divided by 12 factorial over 12 minus 4 factorial times 4 factorial. Okay. Well, this is 6 factorial over 6 factorial, and then 0 factorial is 1, so all of this reduces to 1. So this is 1 times 6 factorial over 4 factorial reduces to 6 times 5, like we just did in the previous problem, all over 2 factorial, which is just 2, divided by, well, as we saw in the previous problem, 12 choose 4 is 11 times 5 times 9. And if we keep simplifying this, 6 over 2 is 3, so we get 3 times 5 over 11 times 5 times 9. 5's cancel. 3 over 9 becomes 1 over 3, so this becomes 1 over 3 times 11, which is 33. So this is 1 over 33, which gives us then that the final solution to our problem was 1 minus 1 over 33 by what we had said at the beginning. Which is 32 33rds. And we have completed that. Okay, finally, let's do one more question, and that's that exactly 3 growth funds are selected. Okay, so this is p of 3. So this means our x is 3. All the other variables remain the same. So we get 6 choose 3 now, because capital E was 6. That is the number of growth funds in our population. 3 is the number of growth funds we want to select. All right, that was our x. And then we get capital N minus E. So that should remain the same. That was 12 minus 6, which is 6. Then we get lowercase n minus x. Lowercase n is 4 again. X this time is 3, so we get 4 minus 3 is 1. And then we do all over capital N, choose lowercase n. Oh, sorry. And what are those in this case? That was 12 and 4 again. Okay, well, I would like to point out, I will move this paper back, but that's actually exactly the calculation we did in the first problem, right? We had 6 choose 1 times 6 choose 3 over 12 choose 4. Right, we have 6 choose 3 times 6 choose 1 all over 12 choose 4. So that turns out to be the exact same as the previous problem, or as problem A. So that is 24/99. And we are done. And that's it for section 5.5, hypergeometric distributions.